Equal and opposite reaction. Newton's third law of motion. In order to use Newton's third law, you must understand Newton's second law, force. Newton's second law states that force is directly proportional to mass and acceleration. Symbolically, this is F equals ma. Mass is usually measured in kilograms and acceleration in meters per second squared, or meters per second per second. Symbolically, kg and m over s squared, or m divided by s divided by s. Newton's third law, equal and opposite reaction. Newton's third law states that for every action or force, there is a paired reaction that is the same magnitude in the opposite direction. Symbolically, F applied equals negative F reaction, or MA applied equals negative MA reaction. Example 1. Two objects of the same mass will collide going opposite directions at the same speed. The mass of both balls is the same, and the velocities are opposite and equivalent. If the collision happens in 0.1 seconds and momentum is conserved, then both the balls must accelerate at 20 meters per second squared in opposite directions. They exert a force of 2 newtons on each other. The objects travel with equivalent opposite velocities as a result of the equivalent and opposite forces that have acted upon the equal masses. Example 2. Two objects of different masses with opposite velocities. The setup of this example is the same as example 1, except for that mass 1 is greater than mass 2, and velocity 2 is greater than velocity 1, such that the total momentum of object 1 is the same as that of object 2. Object 1 is a golf ball and has a larger mass with a smaller velocity than object 2, which is a foosball. The force of ball 1 acts on ball 2, and ball 2 exerts a reactionary force on ball 1. Ball 2 exerts a force on ball 1, and ball 1 exerts a reactionary force on ball 2. The larger ball travels at a slower velocity after the collision as a result of its greater mass. Example 3. Object striking an immovable object. There's only one moving object in this example. The ball will meet an immovable object. Object 1 has a very large mass and no velocity or acceleration. Object 2 has a small mass and a large velocity. When object 2 strikes object 1, object 1 reaction force causes object 2 to accelerate in the opposite direction as its initial travel. The force of friction is great enough on object 1 that it does not move. Object 1 moves away at a constant velocity, just like the other two examples, except for its velocity is 0. Object 2 moves away at a large velocity in the opposite direction as its initial velocity.